This is our student session. I am very impressed with the group of students that have been doing work. Our first presenter is Navami John. She is 16. She's from Myers Park High School. And it says, I asked her to write something down real quick. She says, I enjoy conducting small-scale research projects. I think computer science and programming and biology are some of my most interesting subjects and wanted to combine my interests into a large-scale research project. And I have seen this presentation before, and I am baffled by how excellent she did putting this together. So with that, I'm going to give the floor to Navami.
Okay. All right. Hi, everyone. So as Ms. Hope said, my name is Navami Jain. I'm a sophomore at Myers Park High School. And about the past year, I've been developing and conducting my own two small-scale GIS projects. One of them was through an internship, and one of them I've just been doing on my own. So this presentation kind of just documents like how far I've progressed in each of these projects and the different GIS tools I've been using. So the first one is called Investigating the Response of Foliar Pathogen Magnaporthe oryzae to Rice Plant Roots. I had actually integrated a GIS component into a molecular biology research project that I had done through an internship this past summer. I interned at a genome research center where professors gave me the opportunity to develop my own small-scale biology research project. And professors were, in this particular, the interns were mainly studying rice blast. Rice blast is a severe cereal disease, so it infects the rice plant and inhibits its ability to yield grain. It accounts for nearly 10 to 30% of global rice harvest loss each year. And it's caused by this fungal pathogen known as Magnaporthe oryzae, as shown there. And the fungus infects by spreading its spores, and it causes what are known as these lesions on aerial parts of the plant. And because of the economic importance of this fungus, it's been extensively studied, and it's generally characterized as being a foliar pathogen, meaning it mainly infects the rice plant through the leaf. It does not infect through the stem or the root or any other part. And the way it does it is it basically invaginates the leaf surface and slowly kills the plant. But recently, about 3 to 4 years ago, in countries like Thailand and India and China, where rice is extensively grown, farmers began noticing that the lesions were first actually developing on the root in some plants and then spreading to aerial parts like the leaf, which suggested that root pathogenesis by this fungus was possible. So this directed a whole new direction of research to basically study root pathogenesis of this fungus. And that's kind of how my project developed in the lab. I wanted to further study root pathogenesis by this fungus. So I inoculated the spores on near the root, and I found that before the spores were actually making contact with the root, they were able to adapt their developmental phases and were producing these long string-like structures known as hyphopodia, which you can kind of see in those pictures there. And from here, I won't get too much into the molecular biology part, but I basically researched how different conditions around the root help modulate the formation of this infection strategy. So there are certain conditions in certain when there's a certain amount of nutrients available, the fungus is more likely to infect the plant. And yeah, these are just more results from. So my conclusions were basically current crop protection strategies that only address foliar infection, they should be expanded because because root pathogenesis by this fungus is definitely possible. And there are the conditions around the root, the rhizospheric conditions, definitely play a role in the virulence of the fungus. So this is where I integrated a GIS project added on to this molecular biology project. My question was, can spatial analysis be used to establish other rhizospheric factors contributing to fungal pathogenicity? And I used QGIS because it was freely available, and I performed regression analysis, which basically allows me to correlate key explanatory variables with my dependent variable, which in this case was prevalence of rice blast. And I used the most basic form of regression, It's known as ordinary least square regression because it assumes that the relationship between these variables isn't changing over space. And my area of interest for performing the regression was actually an area in India because rice is extensively grown in this part of the country, and a distinct pattern in rice blast prevalence has appeared over the past decade, but not many studies have actually researched what environmental factors and character and soil factors have contributed to this pattern. Rice blast isn't necessarily more intense in areas with higher crop cultivations, meaning that there might be other factors at play. So here are some of the factors that I considered in my regression. I considered rainfall, I considered altitude, and the reason why I considered these is that in India, farmers practice what's known as intensive subsistence agriculture for wet rice. The rice is actually grown in what's known as a sawad, which is a flooded, irrigated field. So the roots are completely suspended in water, meaning that rainfall and water flow would basically allow the spores to disperse to other plants. So that's why I considered those as potential factors. And then I also considered nitrogen availability in the rhizosphere around the soil, because this was mainly based on past studies that suggested that nitrogen can actually act as a defense mechanism for the plant, but in nitrogen-starved conditions, the fungus actually feels stressed and it instigates its initial stages of pathogenesis. So that's why I consider nitrogen availability. So to sum up, basically my independent variable was my rice blast intensity, and my explanatory variable were rainfall, terrestrial slope, and nitrogen availability. And I performed ordinary least square regression, and once again, that assumes the relationship between these variables does not change over space. And as in linear regression, ordinary least square regression basically produces this model based on the data I've inputted, which is the predicted values shown in that graph there, and then the observed values are the actual intensity of rice blast. So, and then the difference between those values are known as residuals, and I basically want my model to have a very small residual, because that means the model fits my data. So this is my result from my preliminary analysis. I got a relatively high R-squared value, meaning that a lot of the variability in the data can be explained by my explanatory variables. However, there was a cluster of residuals in a certain area of the state of Karnataka, which suggested that there may be a key explanatory variable that's missing from my model. And though I have to still do more research on this, a potential variable that could be missing is acidity levels, because in South Western Karnataka, soils are especially acidic. The model outputted that rice blast occurrence in this area should be high, but in reality it was very low. So maybe acidity affects the fungi's ability to infect the root. The model also outputted coefficients, and coefficients reflect both the strength and the type of relationship between the three explanatory variables in rice blast. So for instance, for nitrogen levels, there is a negative coefficient, meaning there's an inverse relationship between nitrogen availability and rice blast prevalence. But for rainfall and altitude, there is a direct relationship. Altitude, the coefficient for altitude had the highest magnitude, meaning that it has the greatest effect on rice blast prevalence, which was really interesting. And the next steps in my project are to perform geographically weighted regression. This is a more advanced regression form, which I'll probably, I'm seeking help for trying to perform this type of regression, but it basically allows me to analyze any non-stationary relationship. So how is the relationship between these variables changing over space? And also to add more variables within my model. So rice blast, different nutrients like phosphorus and potassium, and as well as acidity. One of the main limitations with this project was because the area of interest was India, and there I had a really hard time trying to find all the data that I needed for this project for that area. And my data sources, I got rice blast data from the International Rice Research Institute, and all the soil factors were obtained from the Rhidomitra agro profile. So that was my first project, and this is my second project. I haven't progressed that much in this project, and I actually am working through a year-long internship for this project. It's called The Use of Twitter to Project the Impact of Particle Matter on Asthma-Related Tweets. So first of all, asthma is a dangerous respiratory condition, and it affects about 25 million people each year. And their studies have proven that exposure to higher level of air pollutants will exacerbate asthma cases. So one of the pollutants of particular interest is particle matter 2.5, and it's even more dangerous than particle matter 10 or because of its size. So particle matter 10 is relatively big in comparison, so respiratory defenses within the lung can actually catch these particles before they do damage. But particle matter 2.5 is so small that it can evade most of these defenses, and it can corrode tissue, lead to respiratory disturbance, and then further the likelihood of an asthma attack. But the general problem for researchers now, especially when studying asthma, is that they, like someone like me, for instance, wouldn't have access to records on asthma attacks and the different respiratory conditions. So this is which is how this project kind of developed. If I assume that if there are more cases of asthma, people are more likely to tweet about asthma, and I observe that there's some sort of relationship between particle matter 2.5 increases in particle matter 2.5 levels and asthma-related tweets. Can I somehow use this information to prepare for future outbreaks in certain parts of the United States? So that was my question in this. So what I've basically done is I've streamed for in the Twitter web server for certain keywords like asthma and ASMA, which is I think asthma in Spanish, an inhaler, and I've used Tweepy, and I retrieved all the tweets in I only focused on the eastern part of the United States for this project. And all the data was available in JSON format. I just had to convert it into a format which I could readily use in GIS. And this is just the script I used to extract the tweets. So this is some of the data I obtained over a 3-month period. One of the limitations with this project was I didn't really obtain enough data for Eastern United States, so I'm still actually collecting tweets. But this is over a period of 3 months. This is all the tweets I collected. And my next step is to see, is there a change in distribution over time? Maybe there were more clusters during the first few weeks, and then they slowly shifted upwards. That would be one of the next steps is basically looking, is there some sort of trend in the distribution of these tweets? I'm going to perform what are known as these space-time kernel density estimation, which basically will help me visualize the space-time distribution of these tweets. There are some issues with accuracy, though, because not all of these tweets are related to the respiratory condition. For instance, asthma might be actually a place. So, so that's a major problem, and the only way I can think of overcoming this is to manually go and look at all of the tweets and see the actual content, but that isn't really the most efficient way. And other drawbacks is that most of the tweets are not geolocated, so I can't infer the location. And I also, as I said, I didn't really collect. I only collected about 200 tweets for a period of 3 months for the Eastern United States, so that's another drawback. and I'm still continuing to collect tweets, and I've collected them for about a year now. And then I retrieved the PM 2.5 data from the AirNow API, and my next step is to basically look at PM 2.5 levels with in conjunction with the asthma-related tweets. And my acknowledgments, I'd like to thank Dr. Delmill and Mr. Desjardins from UNCC who guided me through this second project. So, yeah, that's it.
Oh my goodness. I'm going to go beef up my resume so that when you're running the world, I can come work for you.
No.
That was spectacular. Are there any questions? I have questions about how did you figure out how to go find Tweepy to get Twitter feeds?
That was
Microphone.
That was what my mentors were using. It wasn't really my personal decision, but yeah.
Were there other options?
Yeah, there probably are, but I'm not aware of
Gotcha.
the other. Yeah.
Okay, so one more question. How did you decide to pick those topics?
So the molecular biology, my first project was because of my results from my molecular biology experiment that kind of interested me to go in that particular direction. And my second project, I was kind of limited in what I could research because my mentors were already looking at social media and its potential for predicting health, predicting distribution of tweets. So I kind of had some options from which to choose from for the second project. Yeah.
Amazing. Let's do one in the back first. Go ahead.
So, what made you decide to incorporate an ArcGIS side to this instead of just a report?
So, repeat her question for me.
She asked basically why I decided to incorporate the ArcGIS component into my project for the first project. I took an AP Human Geography class and I learned about GIS, and obviously my mom influenced me because she works in GIS. So I just wanted to see I wanted to see results on a larger scale. I didn't want to confine my project to just a lab experiment. I wanted to see in the real world how are these trends playing out in pathogenesis. So that's why I decided to use. Yeah.
Pathogenesis. It's a new word. Yes.
Did you have a chance to visit the sites in India? And if so, or if not, would there have been some benefits to being on site to learn some things?
I did not get the opportunity to. Do you mean like where rice blast is occurring? No, I didn't. No, I wasn't able to. But that would.
In terms of assessing the factors that are affecting that, would it help to be on site at all?
Yeah, that would have definitely helped. The factors I chose were largely based on like what the research I did and looking at past research papers, and seeing how like there have been some past research papers that say that from like laboratory experiments in this level of humidity and on this the spores are more likely to infect the plant. So it would have definitely helped to actually but I didn't get that opportunity. So yeah.
Keep going. You may have some people who are willing to fund you.
Yes.
I'm interested in your script you wrote for the asthma.
Yeah.
How did you figure out the geolocation of those tweets?
Some.
In the script?
No, that's not in that script. That was just all the tweets I collected, and then I just basically looked for where the coordinates are not null, and then I extracted those tweets. So that's just all of the tweets. I got about like 1 million tweets, and then when I extracted only the geolocated one, it came down to like 500 or 600. So yeah. So.
Any other questions? Spectacular.
Thank
you so much. All right, we're going to have a technical moment because our next set of gentlemen are presenting with ArcGIS Online, and we have not figured out how to make it show up on the computer and on the screen at the same time. So I can make it show up here. However, you guys may have to stand out there to talk about it. So let me find a way here. Can one of you drive for the other? If one of you talks, can the other one drive the computer? Oh, yeah. So let's do it that way. So who wants to go first?
Yeah, it's how it goes.
All right, so somebody's going to have to stand in front of the microphone, and somebody's going to wear the lanyard, and you guys can switch back and forth. I'll do whatever you want.
I'll
You're gonna wear this goes in your pocket, and this we're gonna pin right here to the front of you. There you go.
Okay.
All right. So let me introduce you real quick. You want to go ahead and log in, and I'll introduce you from this side. And this is the problem. Do you want me to turn it back?
Oh, yeah, I was about to say, 'cause I go into my email and do it.
All right.
All right.
While he's logging in, I'll introduce these two wonderful gentlemen.